Hello everyone, welcome to our pre-calculus class. This is about establishing trigonometric identities. So let's look at this. Use algebra to simplify trigonometric expressions, establish identities, and practice maths and homeworks. Our first topic is the definition of an identity. Let's look at one example. Let's look at an example. This is about trigonometric. So uh, say you have a plus b whole square equals to a square plus twice ab plus b square. This one, and then let's say there is another one, a plus 2 equals to 5. Suppose we have these two things. Now look at the difference between these two things. This part here is true for any value of a and b. If you put a equals to 2, b equals to 3, you will see your left hand side and right hand side will come same. Answer will come same. If you put a equals to whatever comes to your mind, you can just put any value here and you will see same answer will come for the same value, same answer will come in this side. Which means that this is true for any value of the given variable. But this part if you look, what is the value of a from this given this set? Let's say this one. And you will notice that if a equals to 3, only then this is true. If I write a equal to 6, then 6 plus 2 equals to 8, but this side is 5, so this is not true. So only for a equals to 3, this is true. And this is the clear difference between conditional equation and identity. This one is called conditional equation because this is true for only some specific value of the given variable. This is a conditional equation. And this is identity because this is true for any value of the given variable. This is the formal definition of identity. For every value of x, which both functions are defined, this one and this one, if you write it one and this we can write it another one. An equation that is not identity is called conditional equation. This is the conditional equation. So this is just like an example. This is another example. Let's look at some more examples here. These are the more examples. So for example, you can write the following identities: x plus 1 whole square equal to x square plus twice x plus 1. This is in terms of x. We can write it as function. Suppose x equals to 2, x equals to 3. For all values of x, this is true. Sin square x plus cos square x equals to 1. And this is our reciprocal identity. All of them are identity because for all values of x, these equations, these are correct. Here these are identity because see, x equal to for some certain values of x, this is true. Sin x equals to 0 degree, not for every angle equals to 0 degree. There are some specific values where sin x is 0 degree. Okay, just like this one, sin x equal to cos x. Not everywhere sin x is cos x. Sin x and cos x is same. Only at 45 degree and the other values, some other values, which is like 5 pi divided by 4 plus 2 pi k, we have sin x and cos x same. Because sin x equals to for sin 45 degree 1 by root 2 or root 2 by 2, and cos 45 degree root 2 by 2. That means at 45 degree their values is same, but sin 30 cos 30 is not same. So for some specific value, these are true. So these are the conditional equations because these are correct for some specific value, not everywhere. These are identity because they are correct for every value. That's why. These are the trigonometric identities. Quotient identities is tan theta equals to sine by cos, cot equals to cos by sine. Reciprocal, cosec equals to 1 by sine theta, sec theta equals to 1 by cos, cot theta equals to 1 by tan. Pythagorean identity is sin square plus cos square equals to 1, tan square plus 1 equals to sec square, cot square theta plus 1 equals to cosec square. So these two line here, this one and this one, they actually come from this. If you divide both side by cos theta, cos square theta, then you will get this one. If you divide both side here, if you divide both side by sin square theta, then we will get this line. This is actually Pythagorean theorem. This means x square y square. We can this is actually sine is y square, so y square plus x square equals to 1 in the unit circle. Even odd identity, this sine of minus theta equals to minus psi theta. Only cos part is our even function and others are odd function. That's why their negative still remains in the given form. So we cannot change them. Just it changes only for cos theta because it is odd function, even function. That's why. Now, why we are discussing this or why we need this? Because in establishing trigonometric identities, these are very important things. In fact, in every sentences, in every line, we will need some rules, need some formulas, etc., etc. Let's look at some maths and let's try to solve some maths where we will see the use of that trigonometric identities, and here you will actually try to do some maths. This is from our book. So let's try to solve some math. Let's do 20 number. This is sec theta into sin theta equals to tan theta. So first of all, how can we have to start from, we will start from our this side because this is a complicated form, so we can simplify it to this. We can try to simplify it to this. This is the easy one. So sec theta equals to 1 by cos theta, then into sin theta. So we can multiply it. This is equal to is enough here. We can multiply it sin theta divided by cos theta. Now sin theta divided by cos theta equals to what? Sin theta divided by cos theta equals to tan theta. So we have got our right hand side. That means this identity is established. So what we have done here is we have written the sec theta formula, then just following some simple mathematical procedure. Okay, let's do another one. Let's try to solve 24 number. So this is sin theta equals to cot theta plus tan theta equals to sec theta. Let's try to from this left hand side, we'll try to bring our right hand side. First of all, sin theta, look, the strategy, when you set your strategy, we have to keep some goal in mind. And like this cot theta, we can easily break it down, but sin theta, we can break it down also. We can write cosec theta, but this is actually taking us to another complication. We have to try to do maths and try to simplify it in some form so that it comes back to sin theta cos theta. Then it becomes easier for solving the maths. So this is one strategy. Another strategy is we have to look at always the right hand side where we are going. So cot theta equals to cos theta by sin theta. Cot theta equals to cos theta by sin theta. And tan equals to sin by cos. So sin theta by cos theta, tan theta equals to. Now do not cut this and this because this is a potential way of doing mistakes. So do not cut this and this, because this is, then it will be a mistake. This sine theta is actually for here and here, so we cannot directly cut it. So let's do LCM inside the bracket, because there are two different things here, this and this. So let's do LCM. This becomes sine theta, then into cos theta. So sine theta cancel out here, then cos theta into cos theta means cos square theta, cos squared theta, plus again cos theta gone, so sine theta into sine theta equals to sine squared theta. Now actually we can cut the things, because now everything is just only one term here. This sine theta and sine theta we can now cut, and this cos square theta plus sine square theta equals to actually 1. Sine square theta plus cos square theta equals to 1, then divided by cos theta. This equals to 1 divided by cos theta equals to sec theta. Which is this? This is what they said us to establish. So we saw that from this actually we can go there. So let's try to solve another math. Let's try to solve 30 number here. So for 30 number, this is cosec, this is cot, cosec, cot. So let's we can actually do another thing here. Okay, let's try to do it this way. Cosec theta equals to 1 by sine theta. Cot theta equals to cos theta by sine theta. There are multiple ways of solving some maths, so feel free to experiment with them if you want. This is good actually. Always this is good if you people experiment with them. So like this way, is it possible? That way, is it possible? Cot theta equals to again cos theta by sine theta. Now again, let's do some LCM here. So this downside will become sine theta. Then this will be 1 plus cos theta. And then this is again sine theta is the denominator here, or LCM. If you do LCM, sine theta is the LCM. Sine theta same, so you have just only 1. And here it is cos theta. Here it is cos theta. So downside you have sine theta and sine theta. So sine theta means sine square theta. And upside we have 1 plus cos theta, 1 minus cos theta. So 1 plus cos theta and 1 minus cos theta. You see a plus b into a minus b. It means actually a square minus b square. It means actually a square minus b square. So we can write here 1 minus cos square theta. 1 minus cos square theta. A square minus b square formula we used here. We used a square minus b square formula. A plus b into a minus b. That means a square minus b square. Now 1 minus cos square theta, actually this means sin square theta from the Pythagorean identity. Then divided by sin square theta. Now you know sin square theta divided by sin square theta. They are same thing, and if you cancel out up and down, it means answer is 1. And they also said to prove that answer is 1. Okay. So yeah, let's try to solve another math here. We are actually just increasing the number of maths here. In the book, they gave a lot of maths here to practice, so all are good. What can I do here? Let's do this math. 37 number. Sec u minus tan u equals to 1 cos u divided by 1 plus sin u. Okay. So first of all, from the sec u, we can write 1 divided by cos. From tan u, we can write from tan u we can write sin u divided by cos u. U is the angle here. Okay. So it is not doing any huge thing here. This is just a replacement of the theta. Sec means 1 by cos, sin means 1 by cos. So now tan means sin by cos. So cos u is the LCM here. Cos same, so we have 1 minus sin u. Now look at this. This is a problem actually. They said us to bring this cos up and 1 plus sin u down, and we have something completely different. So what can I do about that? The idea here is we can multiply up and down by 1 plus sin u just to go to the solution. So we have in the up we have 1 minus sin u. Then in the down we have cos u. Now we will multiply up and down by the same thing, and we can do that always if we want, if we need. One. Now you can say, sir, you did not multiply like this for other maths, because for other maths it was not needed. We have to look at always in the right hand side. For what we are trying to establish, we have to look at that. So we have sin u here. Now we can continue the solution process. So we have 1 minus sin u, 1 plus sin u. Again, this looks like a plus b into a minus b formula, and a plus b into a minus b formula means a square minus b square. So this is 1 minus sin square u divided by downside. Actually, for the downside we cannot do anything, because that's the end of we can actually make it more complicated. So this is already simplified form. The downside is, so we'll keep as it is, this one as it is, cos u, then 1 plus sin u. Now look at this. Basically this is 1 minus sin square u. 1 minus sin square u means actually cos square. 1 minus cos square u. Yeah. So this equals to, we can write this equals to cos square u. 1 minus sin square means cos square. This means cos square. So we have cos square u here. Then the remaining things, all of them are same. So we can write cos u into 1 plus sin u. And now I think now you can see the solution. See, cos u will be cancelled out. There is 2 cos u, so 1 cos u will be remaining there. So this and this, if you consider, there is 2 square means there is 2 cos u, so one of them will be remaining. So this is just only cos u divided by 1 plus sin u. And this is what they said us to establish. This is what cos u divided by 1 plus sin u. Cos u divided by 1 plus sin u. This is what they said us to establish. we can yeah, so this is how that these are some examples, like how can we establish the identities from here. In the book also they have shown a lot of examples how to establish the identities, and you feel free to have a look there. In general, yeah, let me go back. So the general strategy, if you want to think about it, general strategy is, for simplification, think about what formula you have. We have here. What can we do to go back to this kind of thing? So general strategy. Always you have to look at the right side, because that is where we are going. Because for one math, actually, we have multiple direction we can go. Uh, so we have to look at, if we bring something, what should we bring to get our right hand side. Even for this example, we multiplied up and down by 1 plus sign. Why we are multiplying by that? We can multiply it by many other things, right? We could do that. So the reason is we were looking at our right hand side. This is the very important thing here. And the other things are actually more or less same, because this LCM thing, multiplication, they follow the algebra, so that's good. And these are the homeworks, so try to practice this problem from the book. These are the section 7.4. Please read the book of this section. And thank you very much. That's all for today. See you all in the class. Bye bye.